Welcome to The Explainer. Today, we are diving deep into a choice every DevOps engineer faces: sticking with the traditional Jenkins worker node or moving to a modern GitLab self-hosted runner. If you're tired of constantly fighting with your CI infrastructure, then you're in the right place. So here's how we're going to break it all down. First, we'll look at the big picture, the philosophy behind this new approach. Then we'll get our hands dirty, setting up the environment. After that, we'll explore the real magic behind this whole thing: Docker. We'll also cover how to lock down your secrets, run a full pipeline from start to finish, and wrap it all up with a final showdown. If you've been in the CI/CD game for any amount of time, you already know this. How you run your jobs is every bit as important as what your jobs are actually doing. The environment where everything executes, that's the whole ballgame. This is the classic DevOps headache, right? You've got this one single persistent build server, and all your different projects are basically at war with each other. This project needs Java 8, but that one over there needs Java 11. Project A needs Maven 3.5, but Project B breaks without 3.8. It's just a recipe for disaster and builds that fail for reasons that make absolutely no sense. And that really brings us to the core of what we're talking about today. On one side, you have that old-school Jenkins worker node. It's static, you have to manually configure it, and it's a stateful server that you are constantly babysitting. But on the other side, you've got this dynamic, on-demand GitLab runner that just spins up a brand new, totally clean, disposable environment for every single job. Okay, theory's great, but let's get practical. We're going to walk through setting up a self-hosted runner on an AWS EC2 instance. This is a super common setup for companies that want total control over their own build infrastructure. And what's really important here is just how simple this is. We are not building some monster, complicated server. We're just spinning up a basic T2.medium EC2 instance. A quick pro tip: a 2.2.micro is just too small. It won't handle Docker and SonarQube. Then we just open two ports, one for SonarQube to listen on and one for our runner to talk back to GitLab. That's it. The machine itself stays incredibly clean.
And this quote just perfectly captures the fundamental shift in thinking. The main point here is that we are not SSHing into this machine to manually install a specific version of Java or Maven or anything else.
That's it. Seriously, we just prepare the machine by installing Docker. And from this point forward, Docker is going to be responsible for giving us all of our build environments, completely on demand. It's a really simple change, but it has massive implications for how you manage CI. And this, of course, leads us right to the heart of what makes this setup so powerful. It's the GitLab runner's Docker executor. This is the engine that drives this entire modern approach. Think about it like this. Every single job that runs gets its own pristine, perfectly clean room. That room comes prepackaged with every tool it could possibly need: Java, Maven, you name it, all defined in a Docker image. And then the moment the job is done, the entire room just vanishes. It leaves absolutely no trace behind. So when you put these two approaches side by side, the advantages just become crystal clear. You're basically trading all that manual server maintenance and the constant risk of dependency conflicts for clean, reproducible builds where the entire environment is defined as code right there next to your application code. Okay, so let's talk about something that's critical for any real-world pipeline: how you handle sensitive stuff. For our example, we need a way to securely use an API token for our SonarQube analysis server. We can't just paste that into a script. Well, GitLab makes this incredibly simple. First, you generate your token over in SonarQube. Then you just pop over to your project's CI/CD settings in GitLab. You add a new variable, give it a key like Sonar token, and here's the important part: you mark it as masked and protected. This means it's available to your pipeline, but GitLab will make sure it never, ever gets printed out in your job logs. All right, so our runner is configured, our secrets are locked down tight. It is time to actually execute the pipeline. And all of this magic is orchestrated from just a single file living right in our code repository, the .gitlab-ci.yml file. So our pipeline here has 3 simple stages, and each one is going to run in a brand new, completely isolated container. First up, the build stage. Maven compiles the code and packages it into a jar file. Next, the test stage. We run our unit tests to make sure we haven't broken anything. And finally, the analysis stage. SonarQube scans the code for bugs and security flaws, and it uses that secret token we configured a minute ago. And because every single one of these stages runs in a totally clean, isolated environment, what you get is a reliable and repeatable process every single time a developer pushes a change. The whole, well, it worked on my machine problem, gone. It just doesn't happen here. And the proof is in the pudding. The final output gets pushed over to our SonarQube server, and we get this beautiful, clear dashboard. It confirms that our code passed the quality gate with 0 new bugs, 0 vulnerabilities, and 0 code smells. This is the tangible result of a clean, well-orchestrated CI process.
So, let's bring this all home. We'll do a final head-to-head comparison to really nail down the differences between these two worlds.
So really, it all boils down to this. Are you in the business of maintaining a static, stateful server? Or are you defining dynamic, stateless environments as code? See, the old way leads to what we call configuration drift, where the server slowly changes over time and becomes this unpredictable black box. The new way ensures that every single build is consistent and reproducible every single time.
And that brings us to the final thought. Moving to a container-based model like this, it isn't just a small technical tweak. It's a major strategic shift. It's a shift toward a more scalable, a more reliable, and frankly, a more developer-friendly CI process that frees up your team from constant maintenance and lets them focus on what actually matters. So which path are you on?